So good afternoon. We are from group 3 and this is our group member consists of Mutu Kumaran, Putri Mauliza, Kolida Chemenda, Michelle, Tiu Siujin, Mimi Marcella and also Muhammad Shukri. So now we would like to present about thermal processing, which consists of blanching, pasteurizations and also sterilizations. And now I would like to welcome our second presenter.
Thermal process. So basically, what is thermal process? Thermal processing is defined as the combination of temperature and time required to eliminate a desired number of microorganisms from a food products. So in this thermal process, we are going to supply ample of heat so that the food products are able to inactivate enzymes and microorganisms which is obtained due to protein denaturation by rearrange or combine hydrocarbon molecules. So the founder of the thermal process is known as Nicholas Appert. He is a Parisian confectioner by trade, is credited with establishing the heat processing of foods as an industry. In 1810, he received official recognition for his process of enclosing food in bottles, corking the bottles and placing the bottles in boiling water for various periods of time. So to understand the basic principle of the thermal process, the first and foremost, we have to know the optimum times to start the thermal process. So let us look into the bacterial growth phase. There are almost 5 growth phases here. So the best time to start the thermal process is in between the exponential growth phase and also the stationary growth phase, which is known as late log phase. This is because this is the time where the microorganisms is in the healthiest phase and the optical density is the highest. And the second key point to understand is the type of microorganisms we are going to do the thermal process, because there are a lot of many type of microorganisms whereby the optimum temperature is different. For example, mesophils like E. coli, right? The optimum temperature is between 20 to 40 degrees Celsius, and for thermophiles, for example, bacillus, the optimum temperature is 50 to 60 degrees Celsius. So it's better to identify what type of microorganisms and their characteristic in order to start with the thermal process. Thermal process plays a very significant role in eliminating most of the foodborne diseases caused by the pathogens. For example, E. coli, they are able to give a diseases, for example, hemorrhagic colitis, hemolytic uremic syndrome, HUS, which the symptoms faced by the humans is like nausea, fever, stomach pain, and the main source of infection is from the undercooked ground beef or the meat. And therefore, let us look into the processes, the type of processes involved in the thermal process.
Firstly, blanching. The primary purpose of blanching is to destroy enzyme activity in fruits and vegetables. It is not intended as a sole method of preservation, but as a pre-treatment prior to freezing, drying, and canning. Other functions of blanching include reducing surface microbial contaminations, softening vegetable tissue to facilitate filling into containers, removing air from intercellular spaces prior to canning.
There are two methods of blanching: steam blanching and hot water blanching. We can use steam blanchers or hot water blanchers. Steam blanching results higher nutrient retention than hot water.
Next, we move to why blanching. Freezing and dehydration are insufficient to inactivate enzymes, and therefore blanching can be employed. Enzymes are proteins which are denatured at high temperatures and lose their activity. What enzyme causes loss of quality? Lipooxygenase, polyphenol oxidase, polygalacturonase, chlorophyllase, including heat-resistant enzymes such as catalase and peroxidase.
The next one is pasteurization. Pasteurization is a process of heating a food, which is usually a liquid, such as milk, to a specific temperature that below 100 degrees Celsius for a predefined length of time and then immediately cooling it after it is removed from the heat. The purpose of this process is to slow spoilage that caused by microbial growth but will not kill all microorganisms in the food. Instead, it reduces the number of viable pathogens. Second, to increase shelf life of milk. And the last one, to help to reduce the transmission of diseases such as typhoid fever, tuberculosis, scarlet fever, and dysentery. Different methods of pasteurization. First, low temperature, long time. The temperature used is 63 degrees Celsius and held for 30 minutes before cooled to 7 degrees Celsius. This method suits for making yogurt. Second one is high temperature, short time. This method, also known as flash pasteurization, that involves heating milk to 71.5 degrees Celsius for 15 seconds to kill Coxella burnetii pathogen. And the third one is ultra high temperature. This is completely called pasteurization method. It involves heating milk to 138 degrees Celsius to 150 degrees Celsius for 1 to 2 seconds. Steps for pasteurization milk. First, milk chilling. The temperatures between 2 degrees Celsius to 5 degrees Celsius used to arrest bacterial growth and metabolism. This provides a head start at keeping the quality before proper pasteurization commences. Second, preheating or standardization. After bilking, the chilled milk is heated to about 40 degrees Celsius, and the system uses regenerative heating. Third, clarification stage. This stage is essential for removing all foreign matter from the product. Fourth, standardization stage. This stage is important to standardize milk fat to ensure the consistent quality in the market. During the process of standardization, separate the butterfat that is used for making cream. The fifth, homogenization stage. This stage is a physical process of breaking down the milk fat globules into tiny droplets to discourage cream separation. As a result, the milk fat remains uniformly distributed in the milk. Next, heating section. Utilize heat from steam to rise the temperature of the milk from about 60 degrees Celsius to the required 72 degrees Celsius that is effective to kill the Clostridium botulinum spores. Then, holding section. After heating, milk flows into the holding tubes and, in the case of a breach, a sensor will trigger the flow diversion valves to take the milk back to the heating section. Then, milk flows back to the regeneration section. And the last one is cooling and chilling section. After regenerative cooling of pasteurized milk, it moves to the cooling section where chilled water cooling lowers temperature of pasteurized milk to 4 degrees Celsius. The chilled milk is then pumped to the packaging machines for aseptic packaging.
Okay, I will present about pros and cons of pasteurization. First one is pros. Preventing disease such as tuberculosis, brucellosis, and diphtheria, providing a longer shelf life when compared to unpasteurized milk. Pasteurization is vital to making our food product viable. Potential improvement in flavor and texture. Pasteurization process can improve the smell and taste of our product. And lastly is kill the pathogen or bacteria present in the raw milk. Cause of pasteurization is destroy the nutrient and change the flavor. Taste of freshness is lost. And lastly is pasteurization technique destroy all microorganisms in the milk such as lactic acid bacilli, which is beneficial for the health and increase the gastrointestinal and immune system. Okay, pasteurization can be applied in two situations, namely application to dairy industry and pasteurization.
The aim of sterilization is a controlled process used to completely eliminate all microorganisms, which include thermoresistant spores in food. Sterilization techniques is used to enhance the shelf life of food products. For instance, the application of sterilization is used for milk, juice, cream, wine, or salad dressings. foods with discrete particles like baby food, or larger particle food like stews.
Sterilization method can be achieved by moist and dry heat, radiation, filtration, and chemical method. Now that we can see the procedure of sterilization of canned product through three phases, which are phase 1, heating phase until it achieves the exact temperature of sterilization. Next is phase 2, holding phase, which means the temperature is maintained, and cooling phase 3, the product that kept in autoclave machine to cool down. Next, we will move to pros and cons of sterilization. Sterilization can prevent disease transmission, growth of bacteria, and contamination that can damage the product. Meanwhile, sterilization process high in cost because the usage of machine, and for sure there will be a problem with it, and there is chances of skin burning because of the high temperature during process.
So that's all from our group for today. Thank you.